Welcome again to another episode of the Microservice miniseries. The last one turned out to be a chaotic mess. Nothing went as planned, and it was a struggle to make progress in any way. It cannot be helped. What can we do but continue moving forward? We will move forward until we have mastered serverless computing, and in today's video we will get a proper grip on WebSockets. To that end, we will try out SignalR. The vanilla version of it without any of the weird F# libraries getting in our way. Going into it, the main thing we are wondering is if SignalR supports serializing F# union types across platform boundaries. On the JS side there are no types to begin with, so we'll have to use an F# serialization library to turn JSON or binary data into native objects, but on the .NET side we'll see how it goes. If it can't move them natively, we'll also use something like Thoth.json there as well. So let's slowly get started. We'll explore the library piece by piece. Given the experience of last video, one thing we absolutely want to figure out first is whether SignalR queues its messages while it is still connecting to the server. In the previous video, that was what forced us to abandon Elmish Bridge near the end, so we want to make clear whether we will have to implement our own queuing while the application is busy starting up. Indeed, it does raise an exception, but if we look at the code here carefully, we'll see that the start method on the SignalR hub on the JS side returns a promise. Experimenting, we also see that we get an exception if we try to start the hub while it is starting up. But JS programs are all single-threaded, so all of these are not huge obstacles. We could potentially defer the messages ourselves like this. We'll use techniques like this to manage the connection. We should be using array push instead of append here. Also, JS doesn't seem to have a clear method, sorry for the confusion. The last time we wrote raw JavaScript was years ago. We'll be using techniques like these to queue our messages. We'll probably think of something even better once we familiarize ourselves with the library. A big part of our motivation for going with SignalR is that we'll be able to switch its hubs on and off, and check whether they are in a connecting state or whether they are connected. We couldn't do that with Elmish Bridge. With Elmish Bridge at most, we could get a message from the server to signal that the connection is online, but as a consequence we'd be forced to deal what should be a part of the message handling protocol as a part of the UI model. That would be very poor programming that we want to stay away from. The UI just has to call a dispatch function. It shouldn't need to think about anything else. Anyway, what is happening on the screen here is that Master has finally made up his mind to deal with the file lockups plaguing the build script. We've constantly been encountering build failures due to the shared DLL being tied up, and we are going to deal with it here. We are going to get rid of launching the Learn and the Play servers concurrently using .NET Run. Instead, we'll try to do it in such a way that cannot possibly lead to problems, and that would be from the application itself. Honestly, we have no idea why the SafeStack build script is set up the way it is, since the lockups aren't a good look for it. We've had problems during building even with just the client and server being built in parallel. This is an issue with the .NET tool, and we'll switch to pure serial launches as the build failures are so annoying. Yesterday we set everything up, and today we will embark on our foolproof plan to make bidirectional communication work. Let's try running the program. Excellent. Ever since we updated to latest Fable, we've been getting some source map errors, but let's ignore those for now. We'll downgrade the compiler to an earlier version later. The project we had open yesterday was something we got from another YouTuber, but we'll want to set up our own. Our goal for today would be to write our own SignalR JavaScript bindings. We'll be using the Fable SignalR library as a reference, and to speed things up, we'll straight up rip from it where appropriate. We'll double check if everything is in order by comparing them with the TypeScript bindings. Great, now everything is running smoothly. No more source errors, and no more DLL lockups. Let's try setting up a hub and seeing where that gets us. We've gotten the TypeScript bindings purely so we can get IntelliSense support in the editor while we write raw JavaScript. It is going to be very helpful. Now, our first problem is that we are very lazy and don't actually want to put the effort into writing the bindings. So what we'd like to try is to make use of the ts2fable tool to write the bindings for us. Since we are doing a screencast, we were being hasty and missed where the types folder was. We'll slow down a bit just to peek at what has been generated. In our opinion, these look quite good. If you ever need to generate bindings, the ts2fable tool should be what you should reach for first. The tool is far from perfect, but the SignalR library strikes us as being simple, with no generics, so the tool has an easy time with it. One issue we are going to run into is that the types in the bindings are not recursive, so we will have to fix that by hand. Dealing with the errors in the generated bindings was a lot less painless than we thought it would be. Regarding why there aren't any recursive type errors like we had expected, it seems F# has a feature we didn't know about. We've been using an earlier version of F# for our previous work and weren't aware Recursive Modules got introduced. We bet they specifically put this in just for the kinds of bindings we are generating. Also, it seems recursive namespaces are a thing now. Right now we are feeling really pleased at having done this, but if we look more closely, it seems we are missing some types. We are going to pause the screencast here and implement the rest ourselves. It seems there are more type declarations in the base project. It is good enough that we showed how to generate and fix the bindings for this particular video. We'll be back soon. We figured it out. It turns out that those bindings that we got from NPM were outdated. The correct bindings are in fact included with the SignalR project itself. We did think it was a bit strange that there were dependencies in the project on things like jQuery and the browser DOM. So what I want to show you is how to generate the correct bindings. First, go into the relevant project folder for which you want to generate the bindings for. When we tried it without doing that, we didn't get the correct results. Next, make sure you have the most up-to-date version of ts2fable. Next, just use this command. That -e at the instructs the command to look for exports in the current folder. The exporter does need an initial file from which to work from, and that hub connection builder that was missing in the outdated bindings is what is used to create the SignalR connections. Running this will create the F# file with the generated bindings. It looks fine at first, but that is just because it is a raw file on which no type checking has been done. If we copy the code inside into the other file, we'll see a red hell. We'll pause here again and fix the errors by hand. We completed the bindings. As you can see, this is mostly the same thing we have generated using ts2fable. And at the very end, we have exports. In order to use these bindings, all we have to do is import the module in another file. The bindings themselves weren't hard to deal with. The only part that gave us trouble is figuring out that the import attribute can be put on a module. We quite like this solution. We'll release these bindings as a NuGet package in the future. But for now, let's end this video here, lest it turns out like the previous one. What we have done today is important. On the .NET side, the SignalR library is fine, and we can now access it properly in Fable as well. Now that we have this, it is only a matter of making use of it to do what we want. In the next video, we'll do just that, and succeed at what we set out to do in the previous video. Hope you've learned something today. If you have, like and subscribe. We'll be back soon.